Please welcome Arduino CEO Fabio Violante.
Hello. Hey, thank you very much, Zach. Thank you all for being here, and thank you, Zach, and the team for inviting me. Today I will take you through a little journey on Arduino and touch upon the human aspect, because these developers are humans and the inventor of the future are humans. So I don't know how many of you are familiar with our history and how Arduino was born, but I can easily claim I'm not one of the co-founders of Arduino, as you can see there, but I am the grandfather of Arduino. So when I was finishing my PhD program back in 2001 at Politecnico di Milano, a technical university, I was studying human-computer interaction, so for safety critical system, one of the most boring topics you can imagine in the world. So nuclear reactors and air traffic control, complex problem. But there was a funny initiative in Italy. So the school that you see there is called Interaction Design Institute of Ivrea. So a crazy lady decided to start a very innovative school in Ivrea, place where, for those of you that have like white hair, is the Olivetti town. So where they will be building personal computer, competing with IBM. And this was the ergonomy building where they were studying human-computer interaction back in the 40, 50 years ago. So this lady started the school, and they needed a professor of electronics. So I was coming from Politecnico. Politecnico is known for electronic engineers. They said, why don't you teach electronics to their students? But unfortunately, I had to tell to the dean of the school that I knew how to create on paper all the configuration of operation amplifiers, but I have never saw a chip in my life. So, but I introduced to the school the guy on top, Massimo Banzi, that was a close friend of mine, very eclectic person. He didn't have a degree in engineering, but he knew a lot about practical electronics and exactly what they needed, because he was really passionate about design. He was a real, very, very strong software engineer, and he was really patient, and he loved to teach stuff to people. So I introduced Massimo, they hired him, and basically he started working on project with students. The nice thing about this school is this was not an engineering school. The students in the school were psychology, cognitive psychologists, they were philosophers, they were creative people, designers. There were like 2 or 3 engineers. I think some of the co-founders, 2 of them, David Mellis, that now is product manager at Autodesk, and David Quartiers, they were actually students, and they were the 2 only engineers probably in the first class of the school. The problem they had was very simple. So every single project was one of a kind. So people coming up with, I don't know, interactive wallpaper, or you know, any kind of project, interactive lamps, everything required a custom PCB, and was probably not sustainable to wait for 3 months from the beginning of the project to getting a PCB ready from the factory. So they had to come with an idea. So Massimo said, okay, let me find a understandable microcontroller, the famous AVR that we use on the Arduino Uno, and we work around that. And the problem was not only hardware problem, it was also about software. How do we teach programming to people that never saw a line of code in their life? So they come up with the idea of creating this platform, and every one of the co-founders, there was no company, there was no Arduino, nothing. They came up with this idea of contributing to this project to make it easy for them to teach. So together, students and faculty started creating what became the Arduino Uno and the Arduino IDE. Basically, David Mellis wrote the IDE, and Massimo put together the hardware, making also some mistakes, because the connectors, this is a nice story. So the connectors you see on the Arduino Uno that made people crazy for the last 20 years were just a mistake, just put there. They were not compatible with the breadboard, so people still scream at us about that. But this made the platform very sticky, and every development tool you see in the world from silicon vendors, they have this format because it was not compatible with anything else. So this was like a mistake that became an important feature. So Fast forward 7 years, this product went from by word of mouth, no advertisement, just people interested in the platform because it was open source, and that's an important factor. So David Quartier said, why don't we do this open hardware and open source software? So that's basically a contribution, important contribution from David, and Tom Igo, the other co-founder, came with this idea that everything needs to be understandable. So he created the guideline on how to specify everything, avoid the engineering acronyms, and creating the library the way they are built today. So fast forward, they started selling, creating badges for the students, but then creating also product to sell on the market. And there was another guy in the co-founding team that was basically making this board. So they went from 50 units they were using in school to thousands, and then tens of thousands, and then up to 1 million devices. So at some point they decide, okay, we should do something with that. And they come up with the idea of incorporating a company, the company that became Arduino. And as all of you have been, probably many of you have been in startups, we are at the place of startups. One of the most challenging problems of startups is not technology, it's not engineering, it's finding a name for a product, for a company, etc. So they had a nice meeting where they were having an aperitivo in one of the bars in Ivrea, and they were excruciating meetings for the name of the company. So at some point, Massimo was fed up and said, okay, what is the name of the bar we are in? So it's called Arduino. Okay, let's call the company Arduino. So we'll stop the meeting. So basically, Arduino is the name of the bar where they were having this meeting. And so it's funny, but it's the reality. So, but the principle behind Arduino have rooted into very important historical things. So one of the biggest problems when radio and home appliances started to spread, and especially in Germany, like there was this brand called Braun, was training engineers. Guess what? It's the same issue we have today. So there was this designer, Dieter Rams, and you should go and look it up on Wikipedia, that basically created all the design for Braun, and he created also a very nice system to teach electronics to people that were just workers in the factories. Created a modular system that was a very important source of inspiration for Arduino. There was this Professor Eric von Hippel that was talking about democratization of technology and involving the user. This was another source of inspiration. And then there was Olivetti, the typewriters and computer manufacturer. It was a social, a very important social revolution revolving around good design and technology combined. So some of their products, they were a piece of art. So he involved high-end designers. All of these contributed to Arduino. Of course, fast forward, in 2015, Massimo called me and said, Fabio, I need your help because the company is growing. We have some issues that we have to resolve. Would you be available to join me? So I joined Arduino in 2015, and at that point, it was my expensive hobby. So I told my wife, oh, this thing is funny. I will work for pro bono for Massimo for a few days. And then days became weeks, and weeks, months, and years. So we resolved all the issue among shareholders. In 2017, I became CEO, and I started understanding how big was our community. And we have a sort of indistinct portfolio, so just treating companies and makers and educators the same way. So I said, okay, we should, first of all, understand who we talk to. So we created 3 product line specific for education, for makers, but a lot of, Zach talked about cars. So the first maker fair I attended here in the Bay Area, there was a guy from Nissan Renault, was the first people that came to our booth and said, oh, you know, we use it for prototyping. We have a bunch of Arduino. I think I have about 2,000 Arduinos in my lab to do the cockpit prototyping. The second one was Audi. So basically we were a sort of market leader of cockpit prototyping 10 years ago, and probably we are still for certain type of prototyping. So there was a professional market that we were serving without knowing that. So from there, we developed a lot. But before going into the products, what I would like to highlight is the sheer size of our community. So these are real numbers that we extracted from our system. Is 36.7 Arduino IDE download in the last 12 months, okay? And you see the geography there. So this is an impressive number, and it's growing all the time. So when I joined Arduino, we were in the 15 million. Now it's 37 million. This month is growing even more. So this is the 10th of September. We have more this year. So we had to do a lot of work. It's not for free because we had to renovate the IDE, create the IDE 2.0, etc. But from that IDE and that tiny board and the evolution of the portfolio, we enabled a lot of innovation. Drones started with Arduino, the open source drones. All the 3D, open source 3D printing. There were commercial 3D printers that were costing $60,000 each. So all these guys started new industries, billion industries with Arduino as a microcontroller. Healthcare application, ventilation, COVID, we mentioned COVID. Oxford University created a ventilator for developing countries based on the Arduino Nano platform. And it's countless. So basically in Silicon Valley, you can go and talk to anybody. They will have like 10, 15 Arduinos for each startup that has been created in Silicon Valley. So basically, I touched upon the pro part of Arduino, so serving customers that want to go to production. In this case, the revolution for us was really, really big because we had to do a lot of work. So we had 8-bit microcontroller when I joined, and customers now, it's 2025, needed more things. They wanted to run Edge Impulse to do models. So we had to create an entire portfolio of products. We classify this in smart sensing solution, where we have stamp size sensors, like this is a camera that we heavily use Edge Impulse and OpenMV on. We have industrial SOMs, we have automation solution, and the majority of the work has been on the software stack to enable more developers. So more development tool, the Arduino Cloud, and we worked a lot with integration. I don't know, Nakul, how you picked all your recent acquisition, but I was partnering with them before. So Edge Impulse, Foundries.io, OpenMV, they will have a speech here. So these are all our partners. So this is a crucial part of our strategy moving forward. And of course, evolving the knowledge base we have, because enterprise require more precise information. They require better libraries. So we have application libraries group that is developing robust and ruggedizing all the artifacts that they need. So this means basically creating a portfolio that goes up. So we are still in the 500 category here, and we are growing our portfolio. Now we have also a hybrid product with microcontrollers and microprocessor. There is more coming, so stay tuned. 7th of October, there is a final slide, but from there is a lot that is coming, more powerful, let's say, devices. But this is an AI/ML-ready portfolio that is available for you to use. Now, I would like to also ground this with a real story. So one of the biggest area where we see demand from customer is the area of anomaly detection. This is not just a paper stuff that you can see on, let's say, presentations from vendors, but this is something real. So what we get asked by customers is normally the typical solution where you have an industrial machine and a need for predictive maintenance or for understanding early signals of malfunctioning, from stone crushing to the 2 examples that I will show here today, to Margherita that is also working with us on multiple projects. So machine equipped with sensors. We have tiny sensors. We have multimodal sensors, microphone. We work with Syntiant as well. We have cameras. We have vibration with Bosch Sensor Tech here in the valley. So basically, you can create a machine network, normally radio or wired, and use the Arduino Cloud to do provisioning, to do all the data plane, but also integrated within our systems, there is Edge Impulse. So basically, you gather data from the platforms, train the models, and create a solution specialized for your system. This is a little detail about the use case that we will see in a minute. So Arduino Opta is our PLC. Think about an enclosed version of Arduino with a more powerful dual-core microcontroller and industrial interfaces for real applications. So we collect data, we feed this into Edge Impulse, do the analysis of the raw data, and then there is the training part with the Edge Impulse Studio, where people can do, depending on the case, but normally K-means, autoencoders, isolation, forests, so things that, of course, have nice names, but their complexity is hidden, fortunately, in the tool that make it simple for people to use. And the model, then this train model, becomes an Arduino library that you can compile in your code and push on the field using the Arduino over-the-air update feature. So the flow is this one. And this is not just me talking, because this is real. So you have also a lot of analytical tools. This is also a very important part, because signals are complex, and visualization is a good way to make the problem much simpler. And then deployment with the cloud, Arduino dashboards. So normal workflow, real application. So Atlas machine is one of the largest distributor of professional air compressors in the world, in the US. They have more than 5,000 customers. I didn't know anything about compressed air, but I discovered that compressed air is the fourth utility for industrial application, because everything runs with compressed air. If a compressor breaks, or a compressor farm, because they create like hundreds of compressors per customer, if something breaks there, the factory stops. So what they do, basically, they provide compressors, and they provide also maintenance services for those customers. And Atlas standardized on Arduino for automating the sensing and the anomaly detection for their compressor. So they went using Arduino Optas, our sensors, power meters. For the modern compressor, they use also measurement of electricity, profiles, and things like that, all integrated via the Opta Arduino system. But more importantly, they deploy algorithms that right now are talking to the Atlas people and just call the customer and say, you may have a problem on this machine. We are sending our technician to do support. But they're also evolving and creating a business model, trying to replicate their experience, so they are becoming a sort of service provider for this type of industrial customers based on our platforms, the Edge Impulse platform, and their expertise in this sector. And this is one case we are very proud. They are in Kentucky, very nice people. Go online, check them out on the Arduino website. So Richie became also a friend, but really interesting use case. Another problem, probably everyone is using bottles of everything, so from wine to milk to water. So capping bottles is a big issue, and there was Pack Expo last week in Las Vegas, and Italy is very big in this industry for packing and capping. So Arrow is one of the world leaders of this sector. So they have gigantic machine that can cap up to 200,000 bottles per hour. So gigantic machines, you know, filling and capping those bottles. The problem they have is these are, you know, high-speed rotating, multi-head rotating capping machines where a tiny vibration could be caused by poor quality of the material that is ingested. So think about capping 200,000 bottles and then having to rework them. So it is a nightmare. So you have to be fast in understanding what is going to go wrong. And this is basically what they did with wireless sensors, our tiny sensors, the Opta, and the Edge Impulse models to detect the anomaly there. So as a final remarks, of course, the world is really changing with software-defined everything. So that's very important to understand that we are in a different situation right now. What we think is that technology must be open, accessible, and human-centric. Human-centric is the key word for us because we work for humans. So the point is we are committed to not only supporting the AI future, but also to make everyone be part of this evolution. So as you saw when we started this conversation today, we were mentioning the students coming from different backgrounds. The new innovation will not come only from electrical engineers or from scientists and mathematicians, but can come from everywhere. So what is our mission is to keep enabling those people that can bring new ideas, lowering the barrier to entry with Gen AI, with models, with Edge Impulse, with our technology, and with our tools. So thank you very much. Just a final thing is stay tuned for October 7, 4 p.m. In Europe, 7 a.m. unfortunately here. We will have interesting announcement. The campaign is called From Blink to Think. It's I originated this idea. So stay tuned with us, and thank you very much for listening to me today.